Hey everybody, Miss Teacher here. We're going to take a look at how changing the dimensions, how does it affect the area? So we have this smaller rectangle here, which you can see is a 5 by 2. So let's throw the dimensions on there. 5 by 2. And what we're going to do is we're going to triple the dimensions. So triple means times 3, right? We're going to triple the dimensions. So triple, and I'll write down that that's times 3. All right, so if we triple this number, right, 2 times 3, we're going to get 6. So let's make sure I have this rectangle drawn properly. 1, 2, 3, 4, 5, 6. And if we triple this number, 5 times 3 would give you 15, right? So this line, if I drew it correctly, should be 15 in length. All right, let's explore the areas. So the area of this first figure would be 10. 5 times 2 is 10. And if we do 15 times 6, let's use the calculator to speed it up. Remember, it's base times height. We get 90. All right, so let's write that in the big box and remember. So we have 10 square units, we have 90 square units. Now, if we look and see how is the area affected, right? We tripled the dimensions. It's not an accident that if we were to square 3, so let me just write that and just write that we're going to square that. If we square that, that means 3 times 3, and that would give us 9, right? It's not an accident that if we multiply this times 9, that we get 90. It's not an accident. Why? Because area is two-dimensional. You have to square it, right? So if we're going to triple the dimensions, if we square that, we get 9. That's how many times bigger this is going to be than this. All right, so let's just look at another example. What if instead of tripling it, what if we just doubled it? We double it. See if I can shrink this down here to make it double. Let's see. I don't know if this is quite to scale, but so if we go back to the original, this is a 5 by 2. And if I don't know if that shrank properly, but if we double the dimensions, that means that we would take this and multiply it by 2, and we would take this and multiply it by 2 to get the dimensions. So 2 times 2 would be 4. 1, 2, 3, 4. So it looks like it did that about right. And if we do this times 2, we get 10. All right, so remember we doubled it. Let's put that number over here. Now, if we square that, we square this, that's the same thing as 2 times 2. That would equal 4. That means that the area of this should be 4 times greater than the area of this. And if we actually find the area, we already know this is 10. And if we do 10 times 4, we're going to get 40. And this is, right? Isn't this, if we take this number and ask ourselves, what do we have to multiply it by? It would be times 4 to get this. Now, by the way, I should mention that this also works for triangles, right? Or any, quite frankly, this works for any figure, whether it be a trapezoid, a triangle. So if we were going to break these things up into triangles by drawing a line, right, like that, and we are interested in the triangle that's formed on the bottom, right? This would be, the area of this thing would be 5. And what would the area of this thing be? Well, we don't even have to do the work behind it because we already know that it's supposed to be 4 times bigger. So if we take this number and multiply it by 4, we're going to get the area of this, which would be 20. So feel free to do all the work to figure that out. All right, now what if instead of things getting bigger, because this is the small one, right? And this is the large one. What if we kind of flip it around and you're actually going the other way? Like, in other words, you're shrinking things down. So if this is the original, and this is what we're shrinking it down to. Let's make sure we understand. I don't know if you guys can hear the beeping. There's a garbage truck outside. All right, so let's examine, how that would work. I don't have that lined up quite perfectly, do I? So let's try to get that a little bit more lined up. All right, so let's look at it in that direction. All right, so if we think about what are the dimensions of this, right? We know that this is 4 and this is, I think it was 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so even though it's not quite perfect, just pretend that it is. And if we're going to take half the dimensions, we're going to reduce it by a half, right? So half of this would be 2. Half of this would be 5. So if we kind of work in the other direction and you're taking in a larger thing and you're changing the dimensions by cutting it in half or taking half of it, how is the area affected? Well, it's kind of the same idea. If we square this, aren't we going to get 1/4? Because 1/2 times 1/2 is 1/4. So the area of this, which we already know to be 40, if we take 1/4 of it, which remember taking 1/4 of something is the same as dividing it by 4. And if we take 1/4 of this, aren't we going to get this? All right, so that works, again, for any figure, whether it be a triangle, a rectangle, or whatever. All right, what about, let's see if we can change up the dimensions a little bit more. So what if, let me see if I can make this maybe something like this. All right, let's see what dimensions I have here, see if that's going to work. So here we have 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so what if I was going to do 1/4? We're going to change the dimensions by taking 1/4. So when we think about what's 1/4 of 8, remember that's the same thing as 8 divided by 4, then we're talking about a triangle. Let's see if I can clone this thing and shrink it down. We're talking about one that would have, I don't know if that worked or not, but let's see. That would be, if we take 1/4 of 8, that should be 2. So let me see if I can get this shrunken down to 2. And it may not be perfect, but we kind of get the idea. Oh, that didn't really work, did it? That's pretty close. All right, so again, it's not going to be perfect because I didn't reduce it quite right. But if we take 1/4 of 8, that's going to be 2. Let's put that here. And if we take 1/4 of 12, if we take 1/4 of 12, that's going to be 3. And again, pretend it does line up even though it doesn't. So if we think about how is the area impacted, right? If we find the area of this, and you should be able to do 12 times 8 without a calculator. But if we multiply, oops, darn it, there we go. We know that that has an area of 96, so let's put that here. And we can certainly do this in our head, right? 3 times 2, that's 6. Now, if I square this, if you're wondering, what do you have to do to 96 to get 6? You know, we're trying to figure out, well, how's the area impacted? Did you know that if we square this, that's the same thing as 1/4 times 1/4. And if we do 1/4 times 1/4, that equals 1/16. So guess what, people? It's not an accident that if I was to take this number and multiply it by 1/16, which remember is the same thing as dividing by 16, same thing. If I was to take 1/16 of 96, I would get the 6. So the pattern here is, regardless of the figure, whether it be a triangle, a rectangle, whatever, it doesn't matter. If you know the area of the larger thing, and you know what they're doing to the dimensions, which in this case, we're taking 1/4 of it, if you square that, it's going to tell you how the area will be affected for the other one. So this one, this is 1/16 the area of this, right? So it's not, the area isn't also impacted by 1/4 because you have to square it. All right, so hopefully these images helped you to understand this topic a little bit better. Use the shortcut whenever it helps you.